Okay, thanks very much for this very nice opportunity to give this talk. I'd like to say a few words about the role of university. That's what I was asked to do. So about the role of university in data innovation. So let me see if these slides work. Where should I push? Here?
Normally, when I will have a, Mathieu is nearly ready.
Oh.
Okay, now.
Okay.
Okay, that's your slides. Yeah.
Okay, so I'll illustrate what I see as the role of university research in data innovation with a few examples. And let me start with this map of Belgium. This is a map of Belgium where you can see it's not a very common way of, by looking at the different regions to petition the country. So these regions actually correspond not to provinces, but they correspond to social interaction. So this is really a map, and I'll describe in a minute how it was composed. It's a map of how people socially interact in Belgium, and you can see that this does not correspond to interaction as defined by the borders of the provinces. So the way this map was produced, and was produced in my research group by Pierre Deville and with colleagues, and it was widely reported in the Belgian press at the time it was published, is by looking at communication of telephone communication in Belgium. So we had data about half a year, about more than 2 million people, and close to 1 billion exchange, both telephone exchanges and also text messages between people. And we had some information about their location because we had the billing address, not the precise billing address, of course, for private purposes, but we had some information about the zip code. So it was possible to look at the country as a whole and look at all different municipalities, about 600 of them, and look at how intensively one given municipality calls to how intense the communications are between two different municipalities. So if you take, for example, here Blankenberg, and you look at how intensively it communicates with the rest of Belgium, you can see this sharp decrease with distance, and actually it decreased like the square of the distance. This is also something we could measure, and it decreased with the distance. Of course, when you look at the interaction between a region like Blankenberg and one that is located in Luxembourg, it's rather less than if you look closer up. And so we can construct a large network of all these municipalities, about 600 of them, and for each pair, for every pair of municipalities, we can look at how intensively they communicate with each other. Okay, so this gives you a very large network, 600 nodes, and a connection about every pair of these 600 nodes. And on each of these connections, we can measure the intensity of communication. And out of that big network, then, we can look at nodes that are tightly connected with each other, so those that have very strong connection, and try to group automatically those that have very strong connection. And this is what produced this map. So this map has these different regions, where whenever you're in the same colored region, you have strong interaction within the same region, and you have weaker connection with the rest of the other regions. So in some sense, it captures the social interaction in Belgium. And as I said at the start, you can see that these borders do not correspond to the given administrative borders, but that's not always the case. And we do the same experiment here on the same exercise in France. So we had, again, data on France, on mobile phone communication between people in France. And in France, you have about 100 departments that were established after the French Revolution. And much later, less than a century ago, they decided to merge some of these departments into regions. There are about 200 regions in France, 22 regions. And so we did exactly the same exercise with billions of communication between people in France, and looked at how France is socially structured. And there, the map that we produced, that was published in Le Monde in France, as you can see, the colors, the colored region, almost essentially exactly correspond to the administrative borders. So the social structure, except for Paris and also for the region Rhône-Alpes in the southwest, so in the southeast. So in France, the social interaction almost exactly correspond to the borders of the region as they define them, which is not the case in Belgium. And again, was an exercise that was done by one of my students at UCL. So how are these regions defined? How are they clustered? So we have this large network, in the case of Belgium, of 600 nodes, and every pair of nodes has a strength of connection, so you can think of this as a complete network, but in some case, the network is not complete. And this is the LinkedIn network, of which I'm at the center there, and these are all my connections on LinkedIn, and the connection among my connections. And LinkedIn uses, and these are pictures that you can produce for yourself if you have a LinkedIn profile, to look at how your network is connected. And the way, and you can see here these connections for myself, where in some of the group I have my colleagues at UCL in Louvain, some of the group, another group is some of my colleagues at MIT, and then computer scientists, and then friends, and so forth. So these colors correspond and have been automatically produced by LinkedIn. And the algorithm that LinkedIn uses here is an algorithm that was developed in my research group, and some of members of my research group are here in the audience, about a couple of years ago, and is now known as the Louver Method. So the Louver Method is a method that allows to automatically extract from a network groups of tightly connected nodes. So this is something that is rather easy to do for small networks, but when you have thousands or perhaps millions of nodes, and this happens when you look at say, the network of Facebook users, or perhaps you look at the network of Google, of the network of all websites, and so forth. When you have millions of nodes, then it becomes a little bit more complicated to do with traditional method, and the method we've developed is extremely simple. It works for very large networks with millions of nodes, and it uses only very limited storage. So in the initial paper that was published a couple of years ago, we treated a network with 100 million of nodes, close to 1 billion links, and just on a standard PC in less than 3 hours. So the method since then has been used very widely by a number of companies, including some of these companies listed here, and also have been very widely quoted in the scientific literature. So if you look at the scientific paper, and you can look at several thousands of citations the paper has received, you can look just at 2015, showing that every week a dozen of paper actually cite this method and use it for some particular purpose. And I just looked at the latest one that have been used, that have been published. So this was published last week. And these are papers that cite this Louver method for the purpose of analyzing brain, for example, brain connectivity, or CEO central neutrality, so an analysis of a CEO network, or perhaps here the last example is Twitter interactivity. So this method is extremely simple and allows to automatically extract nodes that are tightly connected with each other and weakly connected with the rest of the network. And it works for millions of nodes and billions of links. So with this example, I'd like to illustrate what I see as two aspects, and I'll come to a third one, of what university research should be in data innovation. One of the aspects is that research should be independent, has some degree of independence. The map that's produced here was not ordered or was not designed by political parties. It was just produced automatically with the Louver method, which is a method that does not need to specify the number of regions that you want to have, or not. You do not need to specify the number of nodes you need in any region. So it was automatically produced. And a map like this needs to be produced in a way that is disconnected from pressures from, say, for example, particular economic interest or ideological interest. So first, independence. Second, science is about producing science, new knowledge, of course, but sharing and communicating this knowledge. So the Louver method here, which was developed in the group and that has been widely used now, it's freely available. You can just go on the web, publications are just accessible to anyone who has access to the web, and you can use the algorithm. So this is one of also the goal and one of the role of university research, which of course is not always also shared by research in companies, for example. But university research is about sharing and communicating. So the method there is free for anyone to use. And then there is a responsibility at university research to look at, in particular in data and innovation, to look at topics that are socially responsible. And I'd like to illustrate this with a few more examples. This is a map of France, again, and on the left, it's a map of the distribution of population in France. On the left, it was produced by the National Institute of Statistics. It costs millions, with questionnaires sent all over France, with people filling the questionnaires. Lots of work over months. And the map on the right is one that's produced just in a blink, in a few seconds on a computer, by just analyzing cell phone activity in France. It's an estimate of the distribution of the population. It's an estimate of the population in France, but by just using cell phone activity, and you can see how closely related they are, these two maps. The interest of using cell phone activity, in this case for evaluating the population, is that not only can you update very easily, you can obtain this very easily without having to send questionnaires or to send people around France to look where people live, but you can also update it online almost, meaning that, for example, when people move in the country, when people go on vacation, you can also update constantly the distribution of the population. In France, of course, this is of somewhat limited interest because the information is already available with study like the one that National Institute of Statistics produces. But in some other countries, like in African countries, for example, sometimes it's not the question of the distribution of the population, but even the total population is not known. In some of these African countries, even the total population is known up to an approximation of 30%. So having the information from cell phone activity that allows you to not only estimate the total population, but also the distribution of the population is completely essential for any development policy that you want to implement. So in Africa, any development policy would need at least to know where people are in order to implement development policy. So this is the first example. Another example here is as soon as you have information about mobile phone activity, you have information of how people move around, and you have information about the spread of epidemics that are carried by humans. This is the case of malaria. Malaria is essentially carried through the movement of people, but also for the more recent Ebola. As soon as you understand how people move around, you can predict how the epidemics are going to spread, and you can also suggest ways of containing them. Ways of containing the epidemics of Ebola, for example, is definitely, and proposals have been made in the scientific literature for performing these containments, and these are things that can be achieved by an analysis of mobile phone activity. Another example, as soon as you know how people move around, is the help of optimizing transportation and infrastructure. This is an example that's extracted from a challenge that we organized jointly with a number of partners, where we give access to data about mobility, in this case in Ivory Coast, and we challenged the scientific community to propose ways of exploiting this information for the purpose of the development of the country in Ivory Coast. And one of the winners of the prize of 2 years ago, and I'm going to describe the challenge that's ongoing now. So the winner of the prize of 2 years ago were people that proposed ways of redrawing routes in Abidjan, the capital of Côte d'Ivoire. So this is another example where mobility information about people can help to design infrastructure and transportation. This is the last example, very surprising too. It was done by Toralf Guterres, and I believe that he's perhaps in the room here or he's going to talk this afternoon. The idea was to try to estimate the wealth of people. In Africa, more than 90% of cell phone activity is through cell phones that are prepaid, so they pay for recharging their cell phone. And if you recharge your cell phone by paying $1 at a time, or $10 at a time, or $100 at a time, it gives some indication of how wealthy you are. So you can estimate how wealthy people are. You know where they are too, because you know from where they're making cell phone activities. And so you can get these poverty maps, which is a distribution of how poverty is distributed in the country, which again is a very basic information you need for any development policy in Africa. Okay, so in many of these cases, access to information, access to the data is very difficult because these data belongs to mobile phone companies. This is the reason why we have teamed up with Orange and with the United Nations, Global Pulse United Nations, and Adeline, who is here in the room and is going to talk this afternoon, went to Global Pulse in Orange, Global Pulse in the United Nations to work on some of these projects, and teamed up also with MIT to propose this data anonymized, suitably anonymized, and challenge the scientific community, challenge you to propose ways of exploiting this data in a way that is beneficial for the countries. And the result of all this is going to be presented in 2 weeks at the Media Lab at MIT. You're all invited to this conference. This is an advertisement now. So in 2 weeks from now, where people will report, the scientific community will report on the latest finding on how to use the scientific analysis of mobile phone data sets, how to use mobile phone data sets for the purpose of development or for the purpose of new ideas, of companies, of innovation like the one you represent here. Okay, with this, I believe that my time is up. These are some of the students, the present student and the former student, some of them involved in founding of companies that have been involved in some of the projects that I've presented here. And again, Adeline is presenting something this afternoon, and I recommend you attend her talk. Thank you very much for your attention.
Thank you very much.